Let's talk belt and pulleys and gear ratios. Now, before I continue, there's no gears in a belt and pulley system. So with that being said, the concept that we're going to discuss right now is the same concept as gear ratio, but to my knowledge, there's no name for it. The name that was given to these same calculations for gears was gear ratio. But there's not been a name given to this that I'm aware of. I guess we can call it pulley ratio. In fact, that's what I'm going to call it. I'm going to call it the pulley ratio, even though it's not a real thing. What comes after the equal sign is real, but pulley ratio is not really a real thing. Well, very similar to gear ratio. Gear ratio was out over in, number of teeth on the out divided by number of teeth coming in. There's no teeth on the belt and pulley system, so we skip that one. Next we go to diameter. There are diameters. Diameter of out over diameter of in. Once again, in is referring to the driver. Out is referring to what is being driven. In mechanical advantage speech, this is the effort is in, and the resistance, not the PS3 game. Resistance, I'm not great at spelling. Or writing for that matter. Resistance is the out. So we continue with these true ratios. The torque of the out divided by the torque of the in is the same as the diameter of the out divided by the diameter of the in, same ratio. And then once again, angular velocity is the one that is upside down compared to the other ones. Angular velocity of the in divided by the angular velocity of the out. These three ratios will always be true. These are the same three ratios that were in gear ratio, but they had four ratios. I'm calling it P ratio for pulley ratio, even though it's not a real term. I just made it up because I'm awesome. Let's draw a belt and pulley system. Here we have a pulley. Let's say it's 2 inches in diameter. Let's say this is the driver, so we'll say it's in. And then we have this rotating counterclockwise at 30 revolutions per minute. And it's doing so with a torque of 18 1/3. I hate mixed numbers, by the way, foot-pounds. And over yonder, we have another pulley that's attached to this by a belt. And let's say that this pulley is a diameter of 6 inches. And since it is not the in, that makes it the out. It's the resistance. And let's say that it's traveling at 10 revolutions per minute. And its torque is 55 foot-pounds. So using the equations that we have for belt and pulley ratio, we could say that diameter of out over diameter of in should be equal to the torque of the out divided by the torque of the in, which should be equal to the angular velocity of the in over the angular velocity of the out. Let's see if that's true in this example. If I use the right numbers, then it's going to be true. Diameter of the out, 6 inches. You always label your numbers. Diameter of the in is 2 inches. Always label your numbers. The torque of the out is 55 foot-pounds. Diameter of the, the torque of the in is 18 1/3 foot-pounds. Angular velocity of the in is 30 RPM, and the angular velocity of the out is 10 RPM. Using a calculator or your brain, you would figure out that each of these reduce to 3. So since they're all true, since they all equal 3, that means these equations are true. It means they're always true for belt and pulley systems.